All right, so this is a small video on a mistake. I would call it a blunder. In my previous video, I explained dense sets and I explained it very wrong. Apologies for that. So I just deleted the part where I explained dense sets and I edited that video. It is still there. And in this video, I will explain dense sets. So let's get into it. Now, two things. A set can be dense in another set, like say a set X can be dense in S, or X can be dense in itself, right? So let's understand these two cases separately with an example, of course. Let's say, okay, let me explain like a general idea about what it is. See, dense in S. Something is dense in, like, something is dense in something else. That means this thing has an abundance of this thing, right? Oh, did I say it wrong? Yeah. This thing has an abundance of this thing. X is dense in S, right? The density of X is quite high in S, right? What does that mean? It means that if we take any S belonging to our set, small s, right? If we take any S belonging to the set, this set, and then if we take any delta neighborhood of S, and we take the intersection of this neighborhood with X, then we will get infinite points or infinite elements from X. Okay, let's take it. Let's take an example. Okay, let's say the set of rational numbers is our set X, and S, we can take the set of real numbers. So for, see, any R belonging to the set of real numbers, this is the real number line. Let's take any R, and let's take any neighborhood of R, delta neighborhood, right? So like this is R plus delta, and here we have R minus delta. So when we take this delta neighborhood of R and we take the intersection of this neighborhood with our set of the rationals, what do we get? Obviously we get infinite number of rationals, like infinite number of rationals as well as irrationals, right? So this intersection, first thing, it is a subset of R, right? Yeah, it is a subset of R, right? Will it be true for any set, ponder over it. I will also, if I start pondering right now, this video will stretch too long. Anyway, so you get the idea now. So we can see that this set is in abundance in this set. So Q is dense in R, right? On the other hand, let's take the set of let's take a set Y, which is a set of natural numbers, right? Damn. Okay. So the set of natural numbers, yeah, are natural numbers dense in reals? Like in a similar example, let's take let's take P belonging to R, any rational number. Let's say it is, okay, we will take an example that would make things clear. Let's say this is 1, let's say this is 2, and let's say this is slightly less than 1 by 2. Oh, let's take it to be 1 by 3, right? So 1 by 3 is our P. This is P. Now, what if I take delta neighborhood of P? Can we see any natural number in that neighborhood? Of course not. So this means that real numbers, sorry, natural numbers, they are not dense in R, right? While rationals, they were dense in R. Naturals are not dense in R. Integers will not be dense in R, right? Irrationals will be dense in R. And yeah, I hope this is pretty clear. Now, this thing is said being dense in itself. It is just an extension of the same thing. See? Yeah, just I take it. Let's take the set of irrationals. So I take an irrational number, say root 2, and I form the delta neighborhood, right? So any irrational, this is root 2, any arbitrary irrational, its delta neighborhood, no matter how small that is, it will obviously contain infinite number of irrationals, right? On both sides. Infinite number of irrationals. Okay. So the density of irrationals is very high in delta neighborhood of all the points of irrationals. You take any point belonging to the set of irrationals, you take its delta neighborhood, and we will get infinite number of irrationals in that neighborhood. So the set of irrationals is dense in itself, right? Similarly, set of rationals is dense in itself. Similarly, set of reals is dense in itself. Set of naturals is not dense in itself, because any natural number, you take its delta neighborhood, we won't get another natural number in its delta neighborhood. So the set of naturals, set of integers, it is not dense in itself. Actually, these sets are called nowhere dense, right? Yeah, I hope this is clear. And oh, I feel weird. This is a really small video. Anyway, this is a correction video, so we can allow that. Right? Yeah, that's it. Thanks. And again, sorry for that blunder.